So welcome everyone. My name is Mark and I will be your tutor for this course. So what we are going to do today is we're going to do 1.5 hours. We will focus on the summations. So that's the first topic you will encounter during the QRM I course. And most of the students didn't have them on high school. So it could be pretty difficult. And that's why I'm going to show you a lot of examples and a lot of old exam questions. And at the end of this session, they will be relatively easy. So then you will get definitely all your points for it on the exam. Okay. So who am I? I'm Mark, and I studied economics and business economics just as you. And after my graduation in 2017, I founded the tutoring organization Sophistes. What we do, we offer exam training at university, and basically we are specialized for economic students. So we don't do psychology, we don't do law, we're really focused on the economic side of the university. I've been teaching more than 20 courses in the last 5 years that I'm doing it. And actually my favorite courses are courses like QRM I, Micro 1, Macro 1, Accounting 1. Actually all the first year courses from EBE, I really like them and I love to teach them. I always say teaching is my passion and it gives me energy. And that's why I started this organization, to help you students to study efficiently and to help you if you are stuck with something. Okay. So like I already said, this is the table of contents. So there's a lot that you have to know for this whole course. Here you can see it all in the table of contents. And we will just work with the summations and products today. But it is a really big topic. And you see all the other topics. They don't say you anything yet because you're just in your first week of your course now, like matrices, Gaussian elimination, integrals. But you will understand that when the time is right. Okay, so about today's session, we are with a big group. A lot of students signed up for this. What I do want to ask you, if you could turn on your camera. I really like to see you guys, but it's not mandatory. If you don't want to do it, that's also fine. Don't feel forced to do so. And since we have a big group, you are all unmuted, and that's because some students might make some noises and that could be disturbing. But definitely feel free to unmute yourself if you have a question. The chat is also okay, of course, but I actually prefer it that you just unmute yourself if you have a question. And I will also ask you guys a lot of questions. So I will sometimes call your name to ask you some questions. And I think that's important, the interaction, right? If you sign up for the real training, then we work in smaller groups than today. And then we want to ask you to unmute your audio for the whole session, because then there's a more natural interaction. Okay. So that's basically the start. Then I just say, let's begin. I have some slides prepared, of course. I made them and I think they're pretty good. But I always like to use the whiteboard, just some drawings, some examples. And I will also ask you sometimes to help me a bit with it. Okay. So let's go to the whiteboard. So in summation, it actually is really easy, right? You have some sign. This is the summation sign. And then this is your index sign. So for example, the I or the J or the K, it can be anything. And then here you get some number. Sometimes it's 1, but it could also be another number. And that's basically your starting value. So this is the index sign, and this is your starting value of your series. And then here, on top of the summation sign, you can do another number, something like 3. That's your final number where the series will end. And then here you get some expression. And the expression you get here, that can be anything. And the most easy one you can have is just the I. So your series will look like this. I is 1, that's your starting number. And then it will go in steps of 1. So I is 2, and then eventually I is 3. And it stops at the 3 because that's your ending number. Okay. Because we have a summation sign, you will get pluses right here. And then you just can fill in the expression. So you get 1, 2, 3. And what is this? Equal to 6, obviously. Okay. So this is like the most easy summation sign you can encounter. Oh, I see something in the chat. Hello, everyone. Okay. So now a bit more complicated example. You can also have, for example, that it starts at the 2, goes to the 5. And it doesn't always have to be I. It can also be something like 2i, for example. Okay. Then how I always do it is as follows. You just always write down what you're seeing here, right? So it starts at I is 2, I is 3, I is 4, and I is 5. So that's always your starting point. Okay. And because this is a summation sign, not a product operator, I will also discuss that today, you will put pluses right here, just in between. And then you can do 2 times I. If I is 2, will be 4. Here, if the I is 3, you get 2 times 3, so that will be 6. 2 times 4 will be 8, and 2 times 5 will be 10. Okay. And that's basically how you can tackle this problem. So always remember to write down those I's. It will just help you to don't make any mistakes. Okay. So now we are going to take it together. 4 plus 6 is 10, plus 10 is 20, plus 8 is 28. So this summation will give me the final answer, 28. Okay. Now I will ask you guys to help me. Marcelo, would you like to help me with the next example? Okay. You don't have a mic. Okay, then I will first ask somebody else if you find that okay. Marcus, would you like to help me with the next example? Are you there, Marcus?
Yeah. Can you...
Yes, great. Okay. What would you first do if you have this summation?
First do the 2 times 1 and plus 3 for the first I.
Yes.
And then
maybe you can start with I is 1, right? That's the first value it will get, just
yep.
to get some overview. Okay, I is 2, I is 3, and we do pluses in between, right?
Yeah.
Yes, because it's a summation sign, another product operator. Okay. And what did you say then?
Then 2 times 1 plus 3.
And it is?
5.
Yes, very good. And what will we get here?
2
times 2 times 2 plus 3 is 7 indeed. And here?
9.
2 times 3 plus 3 is indeed 9. And what's then your final answer?
21.
Yes, very good. Okay. So that's the first summation. Do you want to do another example as well?
No, someone else can go for it.
Okay, okay. Thank you for the help, Marcus.
No
who will I ask now? Maybe Manjima wants to help me. Do you want to help me, Manjima?
Sure.
Okay, here we go. I is 2, all the way up to 5. This will be a bit strange. You will just get a constant. So this is a constant. How do we know it's a constant? Because there's no I here in the expression. Do you see that? So for example, here, this was the expression and there was an I, but here there is not. So how do you always start?
I write down I from 2 to 5.
Yes, very good.
And then I write 3 4 times down, as in 3 plus 3 plus 3 plus 3.
Yes,
which
very
is
good. Yeah, so we do pluses in between because we have a summation sign here. And indeed, 3 plus 3 plus 3 plus 3 is?
12.
Yes. Thank you, Machima. Are there any questions so far? No questions? Okay. Then I will erase it. And if I'm too fast with erasing something, just say so, because I can always go back. So now I erase it, but if I'm too fast, just say so and I can get it back for you. Okay. Then the next situation, the product operator. So basically the product operator is the same as the summation sign. You have some starting value, for example, 1, and then your end value, for example, 4. And then here you get some expression, and the most simple one is the I. And just like with the summation sign, I always recommend to start with I is 1, I is 2, I is 3, and I is 4. Okay. But now, because we have a product operator, we will not do pluses in between, but we do the product sign like this. And then it would just be 1 times 2 times 3 times 4. And then this 2 times 3 is 6, and 6 times 4 is 24. And that's the product operator. It basically works the same. Okay. Maybe one more example before we go to an action question. Timmy, oh, your audio is also not working. Shante, would you like to help me? Are you there, Shante? Or Shante? I actually don't know how to pronounce it. Do you want to help me with the next example? No, you're not there.
Hi.
Oh, you're there?
Yeah.
Okay, here it goes. So we have a product operator. Starting value is 2, and it will go all the way up to the 4. And it will be something like 2 plus I. Okay. What will be the way you tackle this problem?
First, put down I is 2 till 4. So
Yes.
2, 3, 4.
Very good.
And then 4 times. Yeah.
4.
4 times 5.
And times 5.
Times 6.
Times 6. Very good. Okay. 4 times 5 is?
20.
And 20 times 6 is?
120.
Very good. That's the answer. Thank you for your help. Okay. So that's basically an introduction for summations and product operators. So that's the starting point. Okay. I see something in the chat. Is that a question or something? From the summation sign to everyone. Okay. So here is an exam question. So I just will give you guys a minute or two to do this exercise. And then eventually I will ask somebody of you to discuss it. Okay. So take a minute or two and try to figure it out. And if there are any questions, just let me know. Just to give you a hint, if you're stuck, you can just write down k is -1. And then here you get the 1. And here you get 2 with the power of k. Notice that I used the I in my example, but it's not necessary to use the I. You can also use the J or the K or whatever you want. Okay. Okay. And maybe you can say in the chat when you're ready or something, then I have an idea how far you guys are. April is ready, but don't feel rushed or anything. When Chima is ready. The summation sign is ready. That's the name you have. All right. Okay, very good, guys. Omar, would you like to help me? Would you like to tell how you solved this question, Omar?
Yeah, of
You're
course.
there.
So you substitute 2 to the power k in, or instead of, the x, k. And then
Yes,
you do k minus 1, k equals
yes.
minus 1, k equals 0, and then k
Good.
equals 1.
Yes. What kind of signs do you put in between? A plus? Yes, a multiplication. Very good. All right. And then I think we have to do this. What is 2 with the power of minus 1? What is the value of that?
0.5.
Yeah, 0.5. It's just a half, right? And 2 with the power of 0?
1.
Yeah, that's 1. And 2 with the power of 1 is just
2.
2, right? It's just 2. Okay. And what will the value be of your answer?
1.
Yes, that's the correct answer. So this action question had the answer 1. That's the only thing you had to fill in. So this was like originally before Corona, you had exercises where you only had to give the final answer, and you had exercises where you had to also give calculations. And here with this question, you only had to give the answer 1, no calculations necessary. Okay. Are there any questions about this one?
Yeah, I have a question.
Okay.
Do you have to add a k equals minus 1, 0, 1? That extra.
This here?
Yeah.
No, I just do that for you guys so that it is clear what we're doing. And
Okay.
it also sometimes helps to count the constant. So I will give you another one here. I will, by the way, erase it if that's okay for everyone. For example, here. Oh,
Just
yes?
to clarify, in an exam, it's written always like the k minus 1 is written next to each other and not really underneath it, right?
Well, it is not always like this. Sometimes it's below it, but here they wanted to force it on one line, because if you have multiple lines and you do it below it, it will cross the next line. So therefore, if you have a text, they sometimes write it like this. So
Thank you.
okay, good question. Okay, then I will go to your point, Armin. For example, how would you do this one? And notice one important thing here, guys. So forget the action question. What do you notice here, Armin?
I mean, I don't notice anything in particular.
Anything?
I mean, it's going to be hard.
It's different than the K. Do you see that?
Oh,
that
yeah.
can also occur. So here your index sign is not part of the expression. Basically, the K is just a constant. So it's a bit like this. I is 2 to 5, and then you could, for example, have a 3, right? How did we tackle this problem? We did I is 2, I is 3, I is 4, I is 5, right? What did you do then here, for example, with this example?
Just
What did you do here?
3 plus 3 plus 3 plus 3.
Yes, exactly. And it was 12, right? 4 times 3 is 12. So here it was a constant. And this is pretty important to remember, when your index sign is not, you don't see it back in your expression is a constant, just like the example here above. So this is just a constant. So how would you tackle this problem, Armin?
I mean, the same, but just a k instead of a 3.
Yes. So you would do it like this, right? You write it down again. And this is helpful because you know how many k's you will have. And then indeed, k plus k plus k plus k is what? How would you write this down?
4k, right?
4k, very good. And that's also something that can occur. So your final answer doesn't always have to be a nice number. Sometimes it consists a letter as well, a constant. Okay. That's why I always like to write this down. So is this necessary? No. Is it helpful to know how many k's you will have? Definitely. That's why I always do it if I'm tutoring. Okay. All right. So here's another one. And you don't know the exact notation quite yet, but you only actually have to focus on this part here. So if what this represents, for example, I will tell that in another session, but you don't necessarily need to know. Okay, just take a minute or 3 or 4, whatever you need. And tell me in the chat when you're ready. By the way, also don't forget that they say simplify it. So if you don't simplify it enough, you also will not get any points. Sometimes, by the way, if you have a difficult question, it helps to separate the question into smaller, easier problems. So that's what I will do here. Marcus is done. April thinks she's done. Marcelo also thinks he's done. Jimmy, all right. Okay. Okay. Clayman, or do I pronounce it correctly? Is it Clemen or Clayman? Would you like to help me? Would you like to help me with this first part of the problem? How would you tackle that, Clayman? All right. Then I would just ask somebody else. Semi, would you like to help me?
Yeah, sure.
How did you tackle this first part? So with the product operator.
So I write down 1, 2, 3,
Yes.
and then k multiplied by k again 3 times.
Mm-hmm.
So you get a k and then a, what's it called? A little 3 on top of that.
Yeah, in the power. K cubed, you can say. K with the power of 3.
Yeah.
Okay,
And
very good.
then
And how did you do the other one?
the same, but instead of multiplying, summing.
Yes.
So that's 3k.
Very good. Okay.
And then simplifying.
Yeah, so k cubed divided by 3k. How can I simplify that?
You can get rid of one k. So you get
Yes, very good.
k2 and then divide by 3.
K squared divided by 3. Very good. This is your final answer. K squared divided by 3. And just to give an extra step for the people that don't see it, basically this numerator is k times k times k, right? And your denominator is 3 times k. So what you can basically do is you can cancel a k in the numerator with a k in the denominator, and then it cancels out. So you get k squared divided by 3. So very good, Sammy, very good. Who did forget the simplification? Because that's the step where it actually goes wrong pretty often, that they just forget to cancel out some k's. Okay. Are there any questions about this one? No questions? All right. So this was basically the introduction. What we will now do is we will go through the properties. And for the properties, I would just use the whiteboard again. So what we did in the summary here, we wrote down the theoretical properties, the definition, but then below it, we plugged in the example so that it's a bit more visual what it represents. The additivity is really intuitive. I will not explain that one, but we will focus on the other ones. Homogeneity, extending terms, constant term, and telescopic series. You do need the properties because with the exam questions, they want to see if you know them, and they will give you some questions where you have to use them. And it really helps with really complicated situations to get the correct answer if you know the properties. So they're important, and they're not that hard, but it's also a bit of studying. So let's start with the first one, homogeneity. Okay. So just take some notes. Homogeneity. Okay. What is the definition of homogeneity? Well, the structure of it is like this. You are multiplying a constant with some expression. So xi is just some expression. It is just a formula or something. It could be just I, but it could be 2i or I squared. It can be anything. And what it is telling you is that if you have this structure, you can basically get the c out of the brackets. So this is what you can do to simplify it. You can just put the c in front of the summation sign. And I will show you why that is allowed. Okay, so let's start with an easy example. I is 1 all the way up to 3. And let's say that my constant is the 2. And the xi, it can be anything, but let's say it's just I, the most easy expression that you can encounter. Okay. If we do it in the original structure, what we would do is we would write down I is 1, I is 2, I is 3, and then we plug in some pluses in between. So 2i will be 2, 2 times 2 is 4, and 2 times 3 is 6. So you would get something like this, right? But now I'm not going to write down the values. I'm just leaving it as 2 times 1, 2 times 2, and 2 times 3. I'm just not filling in the final values already. Okay, what you can see is if they all have the same number number here, I can get the 2 out of the brackets. So I can write this down as 2 times 1 plus 2 plus 3. And there you have it. This 2 is just the c here, the constant. And this summation here is just the summation. So now I prove basically with this example that I can put the 2 in front of the summation. So I can write it, I could also have written it like I is 1 all the way up to 3. That's basically how I can write it down. So if you encounter something like this, you can just get the 2 in front of the summation. That's called homogeneity. Okay. Is that one clear for you guys? I will give you some extra questions after my explanation, but is it clear so far what homogeneity is? You can just plug the C in front of the summation. Okay. Then I will go to the next page. If you did not write it down, just tell me. I can always get it back. The next one in the summary is called the extending terms one. In my opinion, that one can be the most difficult on the exam. In this today's class, I have a relatively difficult question about it and an extremely difficult question about it. You will see later. Okay. So extending terms, that property. Okay. So how it works, the structure of it is I is 1 all the way up to n, and then some expression here, it can be anything. And then you have another summation. And here this ended at n. So then the other expression will start at n plus 1. And it will go all the way up to n plus m, like this. Okay. And this will equal, according to this property, it will equal to I is 1. So now it starts at 1 again, all the way up to n plus m. Okay, so that's the structure. And I think it makes sense eventually, but maybe you in the beginning have to learn it by heart, just a bit maybe. Okay, so let me give you an example. Let's say that we have this here. I'm just going to show you that it really is true what I'm stating here. So this one goes from I to 2. So basically my n is equal to 2. And does anyone know where this one should start then? This one here, according to the
3?
structure. Yeah, it should start at 3. And let's say it goes all the way up to 5. Okay. Then if I fill this in, then here I should get a 1. And notice that those two are the same. So if I have 5 here, I should have a 5 here. Okay. And now we want to see if this really works. So if this is really true, what I'm stating here. Okay, so this summation, that's just 1 plus 2, right? And this summation is 3 plus 4 plus 5. Okay. And what is this summation? That's 1 plus 2 plus 3 plus 4 plus 5. So this is correct. So this property, the extending terms property, it is true. Okay. So that's one thing you can remember, this one. And I'm already preparing you a bit for the upcoming exam question I'm going to show you. It could happen, for example, that you don't get those summations you need. But it could happen, for example, that they say, all right, you're not getting this 3. I gave you a 2 here. So instead of a 3, you get a 2. Then you have a problem, because what happens, because you have a 2 here, it looks like this. And then it doesn't work anymore, this thing. So you have to make a correction. So let me go back. This is the starting situation, and now I will make one adjustment. This 3 will now be a 2 instead. So you're basically adding a 2 here. And now you have to make a correction. It looks really easy. The correction here is that if this goes until the 2, this one starts at the 2, you get the 2 twice. So how do you have to correct for it? You have to do minus the 2 here. So let me make some space here. You have to do minus the 2 because the 2 was twice. So you will now subtract a 2. And that's how you correct for it, for example. That's one, yeah?
But isn't it changing the structure? Like, wouldn't it be then 3 minus 2, 4 minus 2, and 5 minus 2?
Could you repeat the last sentence? Wouldn't it be?
Isn't it changing the structure? Like, wouldn't it then be I minus 2? So like 2 minus 2, but 3 minus
okay.
2.
No, notice the difference that this is what you were saying when you have brackets, but now I didn't include the minus 2 in the brackets. So do you see it here? 2 plus I in between brackets is not the same as this. Because,
So
for example, so notice the importance of the brackets. Very good point. So, for example, this here would be 2 times 2 times 2. And then plus 1. So this here is 9. Do you see that?
Yeah.
So the brackets do matter. So if you have brackets here, you do include the I in your product sign or your product operator. But if there's not a bracket here, if there's not a bracket like here, then you will add the 1 at the end, basically. So do you get that point?
Yes, thank you.
You're welcome. And therefore, the minus 2 was not included. Okay. I see some questions in the chat. Could you put the summation into a bracket? Then the 2 outside, so you make less mistakes. Could you put the summation into a bracket? Yeah, I think, did I also already answer that question? April? Yeah, so that's exactly how you have to read it. So summation, and then you get value minus 2. That's basically what happens here. So it's just the summation and then minus 2. That's the way you correct for it. Okay. Let's get back to the point. So let's say that this is the starting situation again. So this is like the general structure of the extending terms. Now I get a different problem. The tools you were provided on the exam, you will see later what I mean with it, is that this one starts at a 4 here. So instead it doesn't start at a 3, it starts at a 4. How can you still correct for this? If you know this value, you know this value, how would you make an adjustment for this? And you will see later in my example what I mean with it. This is just theory. Which number do we miss here?
3.
Yes. So how do we correct for it?
Can we write plus 3?
Yes. So here we have a 4 instead of a 3. And what we do to solve it, we just do plus 3. And that makes it work again. You will see later why you need this way of thinking about it. But the point now is that you just remember this structure and that you are also thinking about making corrections. You don't always get the exact structure. Sometimes you get something like this, that it starts at 4 and that you have to add a 3. That's what I try to do here, that you are not literally remembering it, but that you get a feeling for the structure and can make corrections on it. Okay. I will definitely show you some examples, so don't worry about it. Okay, the last one that I'm going to show you before we are going to do some action questions is the telescopic series. And I will first write it down, how the structure is. Oh, sorry, I forget one, the constant term first. So first we do the constant term. You already saw it, but now I'm going to show you a nice trick. So the structure is, your starting point is number m, so that's some value. It could be a 2 or a 1 or whatever, all the way up to n. And you have a constant. And what this rule tells you is that you can write it down like n minus m plus 1 times the c. So this summation here will be equal to that. I'm going to show you that that is true, and I'm going to show you why that's helpful to know. Okay. So maybe you remember this example again. The old way to solve it was I is 2, I is 3, I is 4, I is 5. And then we plug in a plus. And then you get 3 plus 3 plus 3 plus 3 is 4 times 3, right? We have 4 times a 3. Okay. But you can imagine that if we don't have a 5 here, but a very high number, for example, 50, it would be a lot of work to write this all out. So we want to have some fast rule to get to the final answer. And that's what the constant term property is for. So what it does, it can help you to give this 4 here. So in this example, if we want to get this 4 here, we could just do n minus m plus 1. And that's how we do it. So n, what is the n here in this example? Anyone knows?
5.
It is the 5, and the m is
2.
2.
Plus
And then we
1.
get 5 minus 2 plus 1 is 4 indeed, right? So 5 minus 2 is 3, plus 1 is 4. So that's very helpful to know. So for example, if we have I is, what will I say? Let's say that I is a 3, and it will go all the way up to 102. And let's say that it will be a 5. Here you would get a really long series, right? Because you have I is 3, 4, 5, 6, all the way up to 102. So here you definitely need to know this rule. Marcelo, how would you solve this here according to the property? Do you have an idea? Oh, Omar is raising his hand. How would you solve it, Omar, if you want to do it?
So basically you just do 102 minus 3
Yes.
plus 1,
Yes.
which is 100, and then times 5.
Yes.
So 500.
So n minus m plus 1 times c. Very good. And then you get indeed 100 times 5 is 500. Very good. Thank you, Omar. And indeed a nice and easy rule, Marcus. Okay. So this is very helpful to remember. I don't remember it correctly, but I thought in the lecture slide, they wrote down something like this. This was it. Do you guys agree with this? I will show you why that works, because if your m is 1, let's say that your m here is 1, what will happen is that you get minus 1 here, and plus 1 there. So it cancels out. Do you see that? So if your m is 1, then you just get n times c, because your m and this plus 1 cancel out with each other. I thought that was in the lecture slide the last time I checked, but I'm not sure if that's still. But so this is like a specific situation. So this is the specific situation here, and that only holds when the I is 1. When your I is not 1, like here, it can be any number, then just this general rule holds. So if you know the general rule, you're fine. But more specifically, you sometimes have this. When the m is 1, you get a really nice n times c outcome. Okay. Is this one clear for you guys, or are there any questions? I'm, of course, going to show you some examples after the break. Okay. Then the last one, that is the telescopic series. And here in the summary, you will find the structure of it and some small example of it. I'm going to show you some examples as well. So the telescopic series is as follows. The structure is like this. You have some starting value, m, and an end value. And it's important, the structure of the telescopic series is as follows. You have xi here, minus xi minus 1. And this is pretty abstract, right? That it looks like this. But I will show you why this is true. So what it basically tells you is that because of this minus sign, a lot of terms will cancel out, and you will only be left with xn minus xm minus 1. This is really abstract. It will not make sense so far yet, but I will show it with an example what it means. Okay. So let's say I would just use the example from the summary first. I is 3 all the way up to 5. And your term is I squared minus I minus 1 squared. So this is basically the situation. Okay. According to the rule, you can just have this as your xi, right? So this here is your xi, and you can fill in the n for I. So you get 5 squared, that's your xn, minus the I squared again filled in, but then with 3 minus 1, with the m minus 1. So you get 2 squared. That's what the rule is. And you don't know why it works, and that's what I'm going to show you now. So according to this rule, this will be the outcome, and I'm going to show you why that is. So do you have a question so far, Mochima?
Yeah, why do you have to take I square as xi and not I, because both of them fall under xi?
Yeah, so this here, you can see the similarity. That's your xi, because you can see that's just below each other, right?
Okay, so it's always by similarity and not by what really is there.
Yes, so xi is just an expression. It can sometimes be just I, but it can also be I squared or 2i or whatever. So, okay, so let me show you how it works, why this will be your final outcome. Okay. You can write this down. So let's act like we don't know that this will be our final outcome. You can write it down like I is 3, I is 4, and I is 5, right? Just the old method. So then we get 3 squared minus 2 squared, right? What will be the next term? It will be 4 squared minus 4 squared minus
3 square.
3 squared. And then the last will be, last
5
term will
squared.
be 5 squared minus 4 squared. Okay. What you will see if you have this structure, that you have some term and then the same term minus 1, that all the terms will cancel out except for the xn term and the x minus 1 term. So let me show you. This 3 squared will be cancelled out with this minus 3 squared. And this 4 squared will be cancelled out with this minus 4 squared. So the only terms you will have left is this 5 squared here, which is the xn term, and the 2 squared, the minus 2 squared. And that's what our rule predicted. So that's the telescopic series. So in the future, you can do it as follows. You take this I squared, you fill in the 5 for I, and then you again take this I squared, and you fill in 3 minus 1 for I, so 2 squared. And that's how you can get your outcome. That's the telescopic series. Do you guys understand why it can be helpful? Because if this one is, for example, a 50, it is really helpful. I will show you in the next example. Okay. So this is example 1. I will give you another example because I understand if this one is easy, is a bit difficult. Okay. Marcus, do you have a question?
And what if it's more than -1? So it's xi minus xi and then I minus 3 or something?
Then it doesn't work. It really has
Okay,
to be
only
minus
one.
1. Yes.
Right, thanks.
Yes. Okay. Other questions from anyone? Okay. Then telescopic series example 2. And then after this example, we will have a small break. Okay. Telescopic series example 2. Let's come up with another example so that you also get some feeling for how to recognize the structure. Let's make this a 2. Let's make this a 5. Then, let's make this one 2 with the power of I minus 2I minus 1. So here you definitely have the same structure, right? This example. So let me write down the structure again. The structure was something like this. I is m all the way up to n. And if you have some expression, and then I forgot the brackets, xi minus 1. All right, something like this. Okay. What we know from the rule is that this will be xn, so this expression filled in with your n, minus the same expression, but then filled in with your m minus 1. That's what we will have left. Okay, let's start by doing it on the old method. How would you do it in the first method? Does your microphone work, Melissa? Do you want to help me with this one? Are you there?
I'm here, but should I have to solve it, but I can't.
No, no worries. I will guide you.
Okay.
So we start with I is 2, right?
Yeah,
And I is
still 5, like 3, 4, 5.
3. Yeah, very good. And I is 5, right?
Yeah.
Very good. And what kind of sign will I put in between?
And the minus.
The plus first, right? So
Plus.
because it's a summation, we work with pluses. Okay.
because I was looked like the up one and I saw the minus, so that's why I say
Oh
that.
yeah, yeah, I see. So this
Um,
is 2 with the power of 2.
Yeah.
2 with the power of 1. 2 with the power of 3, and then minus 2 with the power of
2,
2. And here we get 2 with the power of
4,
4 minus 2 with the power of
3,
3. And then the last term is
5,
5 minus 2 with the power of
4.
4. Okay, let's see. So everybody agrees with this here, right? Which does this term cancel out?
Yeah.
This one?
4.
Yeah. Here we have a positive one. Here we have a negative one. Here we have a positive one. Here we have a negative one, right?
Yeah.
Here we have a positive one. And here we have a negative one. So all the terms cancel out. But except for which term is still in?
The minus 2 over 1 and 2 over
Good.
5.
Yeah, the minus 2 with the power of 1 and the 2 with the power of 5. Hey, that's a coincidence. This 2 with the power of 5, that's the n term, right? If you just fill in the 5 for the I, you get 2 with the power of 5. This term here, that's the m minus 1. The 2 minus 1 is the 1 here. And that's where this rule is for. Do you see that?
Yeah, I see that.
Okay. Let's get to the answer. This is
32.
2 with the power of 5. Do you know that?
Yeah, 32
That's 32.
and 2.
And this is just 2. So that will be
30.
30. Very good. Okay. Why is this rule helpful? Well, if I would make it like this, don't put a 5 here, but I put a 10 there, then you would get a really long series, right? Do you agree with that? But because we know the rule, we don't have to write this whole series out. We can just apply it. What would you then do, Melissa? So now I made this 5. I made it a 10. And what will you get now?
The same. Just
Yeah.
with the shortest one. Okay. So we just put the 2 over 1.
Yeah, so maybe we can just apply this rule. What is the xn here in this example?
Xn 10.
Yeah, 2 with the power of 10, right? The n is 10 and the xn is 2 with the power of 10. So if I take this term, plug n into it, then I do 10 at this spot, so I get 2 with the power of 10. That's what happens here. And what do I have here for this term?
1.
Sorry, yeah, 1. So you take the 2, and here you have an I, and what do you fill in for the I? The m minus 1, so the 2 minus 1 is just 1. Okay. What is 2 with the power of 10? You might want to use your calculator for it.
No, I don't know.
Already see it in the chat.
Yeah.
Thank you, April. Sorry?
No, it's already written. So
Yeah, it's already written.
1024.
1024, according to April. And this is 2. So what do you get?
1022.
Yes. And there you see that the telescopic series is really helpful, because else you would get a really long series, right?
Yeah.
And now you can just do it really quickly. Okay. Is this clear for everybody? And thank you for your help, Melissa. Is this clear for everybody? Or are there any questions?
Thank you.
Okay. Do you guys want to have a small break of 5 minutes or something, just to get some water to go to the toilet? Or do you say we only need to? Yeah, you want to have a break. Okay. Then I would just leave the notes here. and we will continue at 17.6. So in 5 minutes, we would just continue. Okay. See you then, guys. Okay, guys, we will continue. All right, so here you can just read back the definitions and the examples. I hope you also took notes on my whiteboard notes. Here you see the same properties of the products. They're actually really similar. I think you will definitely be able to study it on your own. But if you have any questions, just ask me Later, I will also give you guys my number so that you can ask me for questions. Okay. So what I think we would just do, we would just finish it up with some exam questions. And maybe the double summation signs, I will not record it, but I would just do it after the sessions for the people that want to. Okay. So this you can just read on your own. So let's start with this tutorial exercise. I would just give you a minute or two, and if you're ready, just tell it to me in the chat. Okay. I see already that a lot of people finished it. Okay. Milena, are you there?
Yeah, I'm here. Can you hear me?
Would you like to help me with this question? Which property do you think we have to use?
So we will use constant term.
Yes, very good. We use the
And
constant
because
term.
we have I equals 1, we'll have 10 multiplying 2.
Yes. And what was the general formula actually? If you do it with the m, then this would be equal to?
If n minus m plus 1.
Yes. Very good.
Multiplying c.
Yes. So I always like to use the general formula because that one always works. But indeed, you could use the more specific form because the I is 1. And then you get here, the n is 10, the m is 1, and the c is 2. So indeed, you already said it, 10 minus 1 plus 1 times, what is the c you said here?
2.
Yes. So that's just 20 times 2 is, sorry, 10 times 2. And what do you get?
20. Yeah.
20. Very good. Thank you, Milena. Is this one clear for everybody? This one was not that difficult, I think.
I have one general question.
Yes.
Do you need to write down the first line on the exam, or can you just apply it directly?
Well, in the previous year during Corona, I thought it was multiple choice, so there were no calculations necessary for the whole exam. I don't know if the lecturer is intending to keep that the same. I can ask it, but I'm not sure about it. But yeah, in the previous year, you didn't have to provide any calculations, only the final answer. So, but for yourself, it's always nice to just write it down. Okay. Is that clear? So it's best to just ask your teacher. Maybe he would change it relative to previous year. I don't know. Okay.
Yeah, sure. Thanks.
Any other questions? No? Okay. This one is pretty difficult. It first helps if you can recognize which property you have to use. And then I would start by writing that property down, just the general form of that property. And in a minute or so, I would just give you the first hint. Okay, the first hint I'm going to give you is maybe you guys know which property do we need to use. Does anyone know? Use the,
Extending.
yeah, the extending terms property. How do you know that? Well, and Marcelo also knew it. Well, it sort of goes to n and almost with n+1, actually not exactly. So we need to apply a correction and then to n+m, right? So let me write it down. Oh, by the way, guys, do you find it okay if I go to the whiteboard instead of working in the PowerPoint? If you probably have the summary in front of you, but if not, could everybody maybe make a picture of it? Then I will move it to the whiteboard. So maybe you can make a picture and then I go to the whiteboard. Yes, did everybody make a picture? All right, then I now go to the whiteboard. So the action question, this one is pretty difficult. I think it's the second most difficult question of my PowerPoint. So the extending terms property was like this. I is 1 all the way up to n. Did anyone still remember what I have to plug in here? Anyone remembers it? n+1 indeed, very good. And then here n+m. Okay, and this will be equal to I is 1 all the way up to n+m. Okay, so let's try to fill it in. We first have to think, okay, what will this term be? Do we have this term here? Some structure like that? Yeah, we do. Which one is it? Is it this one here? Or is it this one here? What do you guys think? If you look at the question. This one? Yes. The first one, right? Okay, so we can just copy that. We can write down I is 1 all the way up to, what was it? 23, right? 23. And then normally, according to the rule, this one should start at 24, according to the rule. And then what do you think the n+m be? So you guys already said it. The n is 23. What do you guys think that n+m is in this question? What do you guys think?
45.
Yeah, that's 45, right? Okay. There we go. n+m is 45. Okay. Then it looks like this if we would just use the rule. Okay. But now there's a problem. We don't have this 24. It doesn't start at 24 if we look at the action question. This doesn't start at 24. It does start at 23. So let's go back to the whiteboard. It starts at 23. So this here, it's just the same. I can just copy this. But this one starts at 23 instead. How do we correct for this? Where's the 24 from? That's a good question, Omar. You did agree with me, Omar, that the n is 23. Do you agree with that?
Sort of. Yeah, so you got it from the question, right?
Yeah. I saw that this thing, I could just see that in the question. So the n is 23, right? And then my n plus 1 is 23 plus 1, so 24.
All right. The n, how come you chose the first part, like the one that equals 34? And why don't you try and calculate the with the one that has 45 on top, if that makes sense?
Yeah. So this is always the high number, right? And this one, the n is always the low number. You agree with that?
Yeah.
So this has to be the 45, and this has to be the low number, the 23. That's how I knew that which term represents which term.
Okay, makes sense. That makes sense.
Yeah. Okay. But what was the problem here, guys? Do you guys remember it? So here, this one includes the 23, but also this summation sign is 23, includes the 23. So what's the problem here? We had the 23 twice. And my question to you guys is, how do I correct for it if I have x23 twice?
Minus 23.
Yes, minus 23. Okay. So I subtract the x minus 23, and then you solve the problem. And that's what I meant with you have to change the structure. Does everybody understand this step here? What we did here and why? Tell me if it's not really clear.
Not the x23, to be honest. Can you repeat that?
Yes, no worries. So you agreed with this part here, right?
Yeah, according to the rule, right?
Yeah, according to the rule. That's just according to the rule. But in the question, they didn't tell me what the value of this thing is. So I had to be smart here, because they did tell me what it was with the 23. Do you see that? That one was provided on the exam. That one I know, that's just 78. Do you see that?
Yes.
So I could be smart and I could say, all right, this summation here is basically the same as this here. I know that this is, what was it? 78, right? This summation here is 78. And I know that the x23, what is the x23?
Okay, so the x23 is from the question. So it's...
Yeah. Do you see it in the question, the x23?
Yeah, 6.
That's a 6, right? So even though I didn't know this summation, I did know those two components. And then I can still figure out what it is. Do you see that?
Yeah, I do.
It's a difficult trick here, right? But do you get it?
Yeah.
So this is a difficult question. So don't worry if you didn't see this trick. But that's what I mean with the correction. Or is it for, so if you couldn't think about it yourself, don't worry. But is it clear why I'm allowed to do this? Because this one includes the 23. This one includes the 23. So I need to subtract the 23 to cancel it, to correct for it. Okay, nice. And what is the value of this summation sign? The value is 34 indeed. And then what is your final answer? $106 indeed. Okay. Very good. Then I didn't have to calculate a 6. I could just see it in the text. So here you see that the x23, let me annotate it for you. It was 6. So it was just given to me, Friedrich. Okay. So I would just go to the steps one more time. So first you had to recognize, according to the structure of the things that were given to you, that you had to apply the extending terms property. Then you fill in the extending terms property. That's what you're doing here. And then you use the trick that this one isn't given, but those two are. So that's why we use this trick. And then we can fill in the numbers to get the final answer. That's basically what we're doing. And why is this trick working? Because this one includes the 23, this one includes the 23. So we have it twice, and therefore we have to subtract it one time to correct for it. Okay. Why was x24 is 2 given? Yeah, that's a good question, Sante. That's just to distract you. Yeah, it's to confuse you. Very good. So sometimes in the exam questions, they give you more information than needed. And they say, yeah, the real world also has more information than needed. So yeah, that's just to confuse you. Okay. Are there any other questions? No other questions? Okay. I couldn't finish the whole summary yet, but don't worry about it. First of all, if you have to leave, I have some good news for you. And if you still have some time and energy to continue, I will also do that. So let me go really quick to where we left. So we now finished this question. This is what we will do with the rest of the session. The good thing is that there is still an extra session. So this one was only a really short one of 1.5 hours. If you go to the Suffices website by clicking on this link or scanning this QR code, you will see that there's another extra 2.5 hour session. And in that 2.5 hour session, which is just free, you can also follow the rest of the summation. So if you now have to go, don't worry, you can just watch the rest in that session. For the other students that still have the energy to stay, I would also just continue with some more questions. But if you now have to go, don't worry about it. You can just watch it here in this session. And then something extra, if you really like this session, I'm going to give one in English. If you're Dutch, there's also a Dutch version on the website. You can now get a 20% discount for the whole package. And if you are an Aureus member, you get 15% extra. So you get 35% in total for discount. There are limited spots. So yeah, you can wait, of course, but it could be that it's then already full. Okay. That's just what I want to say. So don't feel bad if you now have to go. Okay, I see something in the chat. It is now online, but when it will be possible, eventually we want to move it to the campus. But for this course, it will be online. And maybe if everybody wants to, we can try to figure something out along the way if we can do it on Canvas. Oh, and you also had a question, Friedrich. I will go back to your question then. But I didn't see your... so the next week is still free. So you can just go to the website, you can sign up for next week, and then the session is still free, but then it's 2.5 hours instead of 1.5 hours. And the beginning of the session will actually be the same, but then I have some more time to discuss everything, of course. Okay. So that's basically it for today. But for the people that want to, I would just already continue today. That's just something extra. That's not part of this class anymore. It's just something extra. And then I will also answer your question about the math, Friedrich. I will. No, we didn't have to calculate the XI. Sorry, I didn't read your question, but I will come back to it if you just have a second. Okay. So that's it. Don't feel bad about it. And then I now go back to the rest. It's not mandatory. Don't feel free to go. You can just watch it back in the next free session. Okay. Then Friedrich had a question. And the question of Friedrich about this question was, did we have defined xi? No, you didn't have to find xi, you have to find this whole thing. So we had to find the whole thing, Friedrich, not only the xi. And then the xi is, by the way, also something that changes. It doesn't have an exact number or something. Does that answer your question, Friedrich? Yes? Or are you still confused about something? Is it clear, Friedrich? Oh, I think he has left the session. I don't know. Okay. Then, oh, here's something in the chat. He left, yes. Okay. You can also watch the recording, of course. Then this, I will just do one more question and then I will also quit. Here you have a really difficult question. It might be the most difficult question that I've ever seen during the exam. And I would just give you guys some minutes to do it. And so just take your time. You're welcome, April. See you next week. And you too have a good day, Manjima. Okay, so just take some time. And like I said, it's really difficult. So I have to say, I haven't seen a student in 5 years that was able to do this question on its own. So don't feel bad if you're not able to figure it out. I've never seen anyone doing it. So you would be the first one if you now know how to do it. It's a really difficult question. You need to have a lot of insight in what to do. So this will be the most difficult question to end this session. And each minute I will give an additional hint. But my experience is that most students are just stuck and they don't know what to do. You're welcome, Melissa. Have a good evening. Okay. If you want to do this question, you can just write it down, make a picture of it, because I will go to the whiteboard again. Okay. Excellent question. Really difficult. You're welcome, Neil. Okay. So what are we going to do? You first have to know which property to apply. And of course, I will also write down again what is given. So what is given is that I1 all the way up to n is n times n plus 1 divided by 2. Oh. And what's also given is that a all the way up to 2a. That's what we want to know. Okay. So this is the information that is provided. And also a is an integer. Okay. Who is completely stuck? I think a lot of you are. Who is completely stuck? Yeah. Nothing to feel bad about. Okay. The first hint I will give, and then it will still be really difficult, is you have to apply the extending term property. That's really difficult to see. That's just one way to do it, to write down the extending term property. So maybe Omer, you can give me the definition. I is 1 all the way up to n, right?
Sorry, the extending terms.
Mm-hmm.
Yeah, so it's the summation from I equals n plus 1.
Yes, very good.
And then
2.
up to n plus m.
Yes, very good.
And then that equals the summation of I equals 1.
Yes.
To n plus m.
Yes. Okay. So this is your extending terms property, right? Which, and this is also really hard to see. They asked you for this one. Which of the 3 is it? And how do you know? Which of those 3 terms do we want to know? The second, indeed. Okay. How do we know that? Well, this is not a 1, not necessarily, indeed. So this cannot be it, because that starts with a 1, and this cannot be it. It has to be this. So what we now know is that A is the n plus 1. So we can write it down like this. I is A all the way up to 2A. So what do we know about n plus m? What is the n plus m? That's the 2A. So that this is really difficult to see, but that's how it is. Does everybody understand this step? Why this thing that we want to know has to be the one in the middle? Okay. I, by the way, also have a really nice other explanation. So this is just my first trial. I will also give you another way to look at this problem. So maybe if this one doesn't click, then I also have another one to help you. So just tell me, I will also show that one in a few minutes. Okay, let's finish this. If n plus 1 is A, then n is equal to, n plus 1 is A, then n is equal to, does anyone know that? A minus 1, very good, Timmy. Does everybody understand that? So what can I fill in here for the n? And like I said, this is a really difficult question. I don't want you to feel bad if you couldn't figure it out. It's A minus 1, right? Okay. Now we are finally there. So we have this here is equal to, and what do I fill in here? What can I fill in here for the n plus m? To A indeed. Okay, so now we have this. So the first thing was that you had to know that you have to apply the extending terms property. That's really difficult to see, but I have another way. I will also show you another method for what we have here. And then you had to see, all right, we have to start at A, not at 1, but at A. So then it has to be that n plus 1 is the A. And then n is A minus 1. Okay, let me give it some color. So this is what we want to know. I will call this the blue summation sign and this the green summation sign. It might help to just interchange the term. So I would just change the order. Don't worry about it. So I would just write down 2a summation I is A is 2a I is 1. So let me give it some color. And then I want to do plus or minus the blue summation. What do you guys think? Plus or minus the blue summation? Minus indeed. So minus the blue summation. So blue plus red is green. Then red is green minus blue. Okay. A minus 1. So I just took the blue summation to the right side. That's basically what I did here. Okay. This is really difficult to get this one started. But why do we want to have this structure? So that I can apply this rule. Because if the summation starts at the 1, so here if it starts at the 1, then you can use that trick, right? So therefore I want to have this, I can use the trick, and this I can find with the trick, and then I can combine it to find the final answer. That's one way to get this structure. So with this, we can apply the tricks that was given, and then I can find the final answer. Okay. Very difficult step to see. I completely agree with that. And I always say, if you want to have a 10 for the exam, then you have to know this question. If you can live with a 9.5 for your exam, then you don't have to know this question. So if you can live with a 9.5, then you don't have to feel bad about not knowing how to solve this one. Okay. The next step that we now can do is we can apply the tricks that was given. Okay. So maybe you guys can now help me a bit. Armin, if you have to apply this trick here that was given to the green summation, what would you choose as your n for the green summation?
2a, right?
2a, right? Times
Yeah.
2a plus 1 here, divided by 2. Do you agree with that?
Yeah.
Very good. Then you get minus the blue summation. What would be the n in your blue summation?
A minus 1.
A minus 1. So the n is a minus 1. And what would n plus 1 be? That would just be
A.
A, because a minus 1 plus 1 is just a. So do you agree that we can write this like this here?
Yes.
Do you agree? Okay. And now we only have to simplify this, and then you have your final answer. So do you agree that if the denominator is the same, we can just get it into the same bracket? Do you agree with that?
Yep.
2a times 2a, what is that?
4a squared.
4a squared. And 2a times 1 is just
Plus 2a.
2a. And a times a is
A squared.
a squared. And minus 1 will be
1.
plus 1, positive. And 1 times a is just a, right?
Yeah.
Okay. do you see one more way, something we can get out of the bracket to get our final answer? What do they all have in common in the numerator?
An A.
So they all have an A in common. And do you also agree that this 4a squared minus a squared is equal to
3a squared.
3a? I will, by the way, do one extra thing. Sorry, I will do an extra step. Sorry. 4a squared minus a squared is 3a squared. And 2a plus a is
3a.
3a. And now I will get the a out of the brackets. A divided by 2 times
3a plus 3.
Very good. This is your final answer. Really difficult question. Don't feel sad about it. I've never seen anyone doing it himself. Just look if the steps are clear for you guys. And by the way, for this thing, I'm going to show you a really nice other method I just came up with. So if this one is unclear, just stick for 2 minutes and I will show you another way to find this one. But are those steps here clear? Or are there any questions about those steps? No questions? Okay. Clear. And by the way, maybe we could also take out the 3 here. So maybe you want to also take out this 3 here. So you could write it down like this. That's also doable, of course. Okay. Let's go to another way to get it. How can you also get this one here? Let me show it. Okay. So we had this trick that if it starts at 1, very important, if it starts at 1, you could write it down like this. Oh. And also we want to have I is A all the way up to 2A. So basically the problem here was that we couldn't apply this trick. Why not? Because it starts at A and not at 1. And therefore we're not able to apply this trick. But the key thing here was that, 1 second, else my laptop will fall out. Where's my recharger? Let me have a look. So the key thing was that even though we couldn't figure out this value here, we were able to find those 2 separate values. That's the key thing here. So how do we find this here? It works as follows. This line here looks as follows. A plus A plus 1 plus point all the way up to 2A. That's basically what we want to know, right? And to get this series, I can do the following. I can use a series that starts with 1 because that's really helpful. So I can do 1 plus 2 plus 3 plus point. All the way up to A minus 1. Plus A plus 1 plus point plus 2A. And what do we have to subtract from this series? If I have this series, what do I need to subtract from this series to get the other one? Anyone has an idea? 1 plus 2 plus 3 plus. What do I need to subtract? Anyone? So I want to get this part here. And now I have this green Sorry? No, no worries. So we want to have this summation. Do you guys agree that this summation is equal to this series here, right? Now assume that I have this series. What do I need to subtract from this green series? What do I need to subtract from this green series to get the red series here? What do I need to subtract from it? Shall I tell it? This here. Do you guys agree with that? So to get this red series, I take the green series minus this series here. Let's call it the blue series. See if you agree with this. 1 minus 1 cancels out. 2 with 2 cancels out. 3 with 3 cancels out. A minus 1 and A minus 1 cancels out. So what am I left with? With the red part. Do you guys agree with this? Okay. And I'm not saying that this is easy, but that's how you could also look to it. And why are we doing this? Because if it starts at a 1, then we can apply this trick here. So now I have simplified this summation into this green series. Could somebody tell me what the summation is of this green series? At which number does it start? It starts at, no, not the green series doesn't start at A, it starts at 1. That's very nice. Then we can apply this trick. What's the ending number of the green series? No, it's 2A. Do you see that? That's the ending number of the green series. 2A indeed. So this green series, I will underline it. This green series goes from -1 to. Okay. And then this blue series, what is from this blue series the starting point? Starting number. That's a 1. And what's the ending number of it? The ending number is a minus 1 indeed. Hey, and that's the same thing here. So now you have simplified it. You have basically said, all right, I want to know this thing here, the red summation. I have the red summation. I don't know that, but I know that the red summation is equal to the green summation minus the blue summation. Do we see it? And now I know that this is true. Then I can apply this trick that you're seeing here. Then that's what you're seeing here. So again, this thing here is another way to get this thing. So you can use the extending terms formula here if you find that easier, or you could use this series trick. And it might be that you want to watch this recording back and want to watch it over and over again. But I hope you will eventually see what we're doing here. It's really difficult. Don't feel bad if you're not able to come up with it yourself. Are there any questions so far? Because this is the solution. So I now showed you 2 ways to get this thing here. One is the extending terms formula. And the other one was with the series that you do the green series minus the blue series to get the red. Are any questions about this question? No questions? Okay. Then I will do a really easy, and now let's say really a normal one. This is pretty the normal level of the exam. One last question, and then we call it a day. This is like a normal question, not an extremely difficult one, not extremely easy, just a normal question. And then we call it a day. And also notice that in the solution sheet, I was really fancy with all the properties, but I will show you in an easier way here. So after this, we call it a day. Tell me in the chat if you're finished. No, that's not correct, Adam. The minus 12j is correct, but the 9i is not correct. You forgot to fill the I in. Okay. By the way, what I want to show with this example, with this action question, is even though you have all those fancy properties, it doesn't necessarily mean you have to apply them. So you can just start with the old method here, where we started this session with. Sometimes it's not necessary to use the properties. So that's what I recommend to do here as well. That's my first hint. Marx is done. Omar is done. Can I help somebody else? You can just unmute your microphone. We now don't have that much people anymore, so. Timmy is done, very good. Adam, is it okay if we do the first part? Could you unmute your microphone?
Yeah, of course.
If you fill this in, you get 2
2
plus
9 minus 4.
minus. Yeah, you don't fill in the j. Why not?
I don't know.
Because your index number is not j. Therefore, you just leave it as a j. You can only fill in the I.
Okay.
It's basically like a constant.
Okay.
And what do you get here?
2 plus 12.
12 minus
4j.
4j. And here?
2 plus 50.
15 minus
4j.
4j. All right. Is this step clear for everyone? And now we can just take it all together. This is 11, take your calculator. This is 11. plus 14. What's 11 plus 14? It's 25, right? And 25 plus 17, what is 25 plus 17? 25 plus 17, it's indeed 42. So that's the number in our final answer. And then minus 4j, minus 4j, minus 4j is equal to minus 12j indeed. And that's your final answer, 24 minus 12j. Are there any questions here?
So you can't simplify the
Mhm.
answer, or?
No, this you cannot simplify it any further. This is the most simplified version you can have.
Okay.
So, any other questions? No? Then that's it for today, guys. Thank you all for being here. And maybe I see you next week with the other free session from the Summations website. Okay. You're welcome, Clayman.
I have a question.
Yes.
So this course or this like lesson is part of the, or it's a free trial for the course that is paid, right?
Yeah, this is free, but also next session is free. And then eventually it's paid, of course, yes. But
and is next session about the same thing about today, or is it about the next topic?
well, it first had some overlap, but now I'm thinking maybe I will do it so that the other persons that didn't attend here first have to watch this recording so that I can just continue on what I did here today.
Okay.
I have to discuss it internally what's smart to do, but that's what I'm thinking now. But I'm not quite sure yet.
So for
I
now,
think that makes more sense.
yeah.
Sorry?
So for now, there's nothing I have to worry about, like signing up for the course or anything, right?
Yeah, you can sign up for the next trial session, of course. It's just on the Summations website. And I have to think if I will make an overlap or if I would just build on top of this session. I think I will do the last thing.
And the paid one,
it's
when does the paid one start?
not next week, but the week after that.
All right. Okay.
Okay.
Thank you.
You're welcome, everyone. Nice to hear that it was helpful. And maybe until next week.
I have another question.
Yes.